Okay, now I want to look at an example of where you get one triangle. And again, I'll do the little H thing, but normally that would not be something I do, but some people like it, so I'll go ahead and do it. Again, you want to put your angle here with the side across from it, which is what, 3, and then my other side B is here. And if I cared about my altitude or height, I would go ahead and put that puppy in there. And again, sine of 50 degrees equals opposite over hypotenuse. And put a 1 there if you like to. So I get h equals 2 sine of 50 degrees. And so type that in your calculator, and it looks like I got about 1.532. And so if you look at that, you're like, oh, you know, that's long enough. This 3 is long enough, so I should be able to swing it 2 ways. Why am I not getting 2 triangles? Well, swinging out, you can see, yep, everything connects. That's awesome. But if I swing it the other way, notice that 3 is actually longer than 2. So if I swing it, it's going to swing outside of my triangle. It's going to swing that way. And so there will actually be a gap off here if I try to swing it the other way. I can't swing it inside the triangle like I could before. So outside like this is awesome. I have a nice closed triangle here. But if I try to flip it the other way because 3 is longer than 2, it will actually, like a door opening, it's going to go beyond the inside of my triangle. And so then again, I can't make a triangle like that. So if you're going to do this little trick, not only do you have to make sure that, yep, this is, you know, long enough to close a triangle, but also if this value is bigger than this side over here, you're not going to get 2 triangles, because when it swings over, it's going to swing outside the shape and you're not going to be able to make a triangle. But again, like I said before, I never do that. So all I do is law of sines. So again, I would just kind of make a rough sketch of my triangle. So there's A, and then let's see, here's B, and then there's C. All right, so I'm just going to do my law of sines. So sine of 50 degrees over side A, sine of B over 2, and sine of C over side C. And just like I did before, I'm going to do my little proportion right here. So I'm going to take sine of 50 times 2 and divide it by 3. So let me do that quick here. So I have sine of 50 on my calculator times 2, and I'm going to divide it by 3, and I get the sine of B equaling 0.510669, dot, dot, dot. And so that ratio works as far as inverse sine goes, because it's between -1 and 1, so that's awesome. So I can do my inverse sine to both sides, and I get B equals, so I'm going to hit my inverse sine, and then let's see what second answer here in my calculator. So I get that angle B is, let's see, 30.7 degrees. So again, to get the other angle, if I know angle B is what, 30.7, I can take 180 degrees minus my 50 and minus by 30.7. So let me go ahead and do that. So 180 minus 50 minus 30.7. So let's see. So angle C is approximately, let's see, what do I have there? 99.3 degrees. And so the last thing I need to do is figure out side C. All right, so if I want to, I could put in my 30.7 degrees right there. And I could put in my 99.3 degrees there. And again, I need to do a proportion. Again, I can use this middle one. There's some rounding there, but obviously I have some rounding here, but I tend to go with my original usually. So I'm going to kind of bypass that middle one a little bit and use that proportion. So I'm going to multiply those. So I have my sine of 99.3 times 3 And I'm going to divide that by what, the sine of 50. So type that in, and I get that side C is approximately, what, about 3.9. And again, the unit would be feet or inches, or, you know, pretty much whatever I want to go with there. All right, so let's see, I know all my angles, and I know my sides, so I'm good. But again, I should kind of be expecting two answers. Anytime I do inverse sine, I realize that on the unit circle, there's not just one spot where that happens. So when I did inverse sine, I got this angle right here, and that angle was what, 30.7 degrees, and there's a value there, right, an xy coordinate, and there's a mirror image of that on the other side. So if I look on the other side over here, there's the mirror image, and the y values are actually going to be the same, or the sine values are going to be the same. And so I need to figure out that angle right there. Well, again, these are mirror images, so this is 30.7 in there. So if I take 180 minus that 30.7, I can get that other angle. So 180 minus my 30.7 is what? 149.3. Well, that's a slight problem, because if you look at our triangle, we already know that this guy's 50 degrees. And so now I am saying that, let's see, what am I saying? Angle B, which is over in this corner, I'm saying that it's now 149.3. Well, we know there's only 180 degrees in a triangle, so obviously this is not going to work. So just by checking it, I can tell that there's only one triangle, and I know that up here I solved for it, so I'm done. So again, I never do this because I don't need to. When I check inverse sine, I always check for the second angle just to see if it works. Obviously, if it's more than 180, it doesn't work, and so I'm done.